Hey guys, so now we're going to talk about the substitution rule, which may also be called the USub. Now this is going to be the very first thing you guys learn in calculus when it comes to integration. It is also very important. You guys can think about it as the chain rule when it came to derivatives, right? So anything from now on can have a USub in it. So now let's go ahead and talk about when we use USub and how we use it. So let's get started. So here we have that when basic integration rules aren't enough, we use the substitution rule, right? So I gave you guys a pool of indefinite integral rules, and when you can't solve your problem, when you can't find your integral with just that, you're gonna run to substitution rule, to the USub, right? So we're also gonna introduce two new variables when it comes to substitution rule, and they're gonna be called the U, as well as the du, right? And that's kind of what I have it here in this diagram, that you're gonna go from integral of f of x dx to integral of f of u du. So the main idea is that when you're integrating in terms of u, or when you do the u substitution, everything is going to be in terms of u after you change it, right? And I'm going to show you guys exactly what that means in just a second. And then also, the last bullet point we got to go over is that this technique is also referred to as a USub, right? So you guys are going to be hearing me say, hey guys, we're going to use USub, or whatever this problem requires USub. What I mean is the substitution rule, right? No one actually says the whole name, we just say USub. And then the most important technique that we need to have when it comes to USub, which is the beginning of the whole problem, is how do we choose the U, right? We need to identify the U. And that is always going to be a question that is not really a straightforward answer, right? I can't just tell you, you always do this for U, right? So what I decided was, with all the problems that I've seen from USub, there's mainly 5 different types of U's that you can pick, right? So I made sure to lay them all out here for you, and that is going to be the inside of a parentheses, a denominator, an exponent, a trig function itself, or the angle of a trigonometric function, right? So those are the main five types of U's that you can pick, right? So let's go over those examples, and then we're gonna go into the step box where we actually go into solving it, right? But we can't solve substitution rule problems without first identifying the U correctly, right? So we're gonna take some time to identify the U and find the du, which just means the derivative of U, and then we're going to move on to actually solving problems, right? So let's get real good at actually picking out our U, and then we'll move on from there. So when I mean the inside of a parentheses in the first type of problem, is that usually you can think about this as the inside of a parentheses, or whenever you have a function raised to a power, right? So that's another way to look at it, right? So here we have 2x plus 1 raised to the 5th, right? So you can think about it as the function being raised to the power, that's going to be your u, or the inside of this parentheses, right? So in this case, our u is going to be that, which is going to be 2x plus 1, right? That is going to be our 2x plus 1. And then, after we have identified our u, we're going to be able to find our du, which is going to be just the derivative of 2x plus 1, which is going to be 2, but we need to add this magical dx at the end of it, right? We need to add a magical dx at the end because we derived the 2x plus 1 in terms of x. So then we need to add that dx at the end. And I'll explain how we're going to use this whole u and du thing in the step box in just a second. But first, let's get real good at just identifying u's, right? So that's the first type of example, when we have the inside of a parentheses or whatever the function being raised to a power is. It's going to be a very easy way of being like, hey, I need to use USub. Okay? Then the next one is going to be the denominator of a function, right? So if you have a fraction or a rational function, you're most likely going to have the denominator of the function being your u. So in that case, your denominator is going to be x plus 1. So your u is going to be x plus 1. And the du is going to be the derivative of x plus 1, or just 1, and then we need to always multiply it by a dx, right? So don't forget to make sure that you have your derivative and then your dx of u at the end. So that is the second type, right? And you can also mix and match these rules, right? Let me just give you a little idea how we can mix and match this, right? So for example, if I give you this problem, if I give you the integration of 1 over x plus 1 or 2x, let's have 2x plus 1 to the 5th dx, right there I'm mixing both rule and the first rule and the second rule together, right? Because I have a fraction which has a denominator, and I also have a function. Raised to a power, or the inside of a parentheses, right? So in this case, we'll discuss in the examples what would be the u here. Would it be the whole denominator, or would it be the function being raised to a power inside of the denominator? We'll discuss that in just a bit when we do the examples and the practice problems, right? But just keep that in mind that you can mix and match these rules together. We're just going over the first 5 basic rules, okay? So the third rule is going to be the exponent, right? So what I mean by the exponent is going to have an exponential function, or we're going to have like an exponential function, and we're going to have an exponent, and that is going to be our u, right? So you guys remember when deriving e to the x's, what made the problem hard was the exponent, right? Well, in this case, it kind of relates to integration. When we're integrating them, what we care about is the exponent of the function. So in this case, our u is going to be 5x, right? And then that means that our du is going to be the derivative of 5x, which is 5, and we cannot forget to put our dx at the end. So that's when it comes to exponents, right? And then we're going to go ahead and talk about our fourth one, which is a trigonometric function itself. And what I mean by a trigonometric function itself is that in this problem, you're going to have an integration of sine and cosine, right? So there's an example when you have two functions multiplying with each other. You have two functions multiplying each other, so we know we can't do this. And we can't distribute here. We can't use that technique that we use in indefinite integrals. So what do we do, right? So what we're going to do is we're going to pick one of the functions, whether the sine of x or cosine of x, to be our u, right? And in this case, it doesn't matter which one we pick, right? So we actually have two options for our u. Our u can be just sine of x, our u can be sine of x, or our u can be cosine of x, right? And it actually makes no difference in this problem, because the way the problem is set up, there is no difference in how you choose your actual u, right? So it means that we can have two possible du's, which are going to be the derivative of sine is going to be cosine, right? And then we cannot forget our dx. Then we also have our u being cosine, so our derivative is going to be negative sine, right? And then we cannot forget our dx, right? So if you guys do the whole problem following the procedures using either u, you'll be good to go and you're going to get a right answer, right? So now that I can kind of switch this up, I can tell you guys that think about this problem. I'm just going to lay it out there, and I'd actually solve it for you. I'm just going to lay it out there. I'm going to have, what if I have sine squared of x and then cosine of x dx, right? I can't fit the dx there, but you guys know it's going to be there. So what makes this problem different is that I'm just going to add a sine squared of x and a cosine of x. In this case, would it make a difference which one is your u and which one is your du, right? Because you can think about that sine function as a function raised to a power, which is how we refer to here as this u, or as an inside of a parentheses. So just think about that little switch that we can have in that problem, where we go from having two sine and cosines, which are exactly the same, to having one raised to a power and one not to raised to a power. Does that make a difference on what your u is? And we'll discuss that now in the examples, right? So USub, the idea is going to be the same all throughout, but there can be a little tricky stuff here and there to kind of throw you off. And once you figure out the u, you're like 85% there. Trust me, because once you figure out the right u, from there on it's just a step box that we follow, and we just go down the step box. So let's go ahead and talk about our last one, which is going to be the angle of a trig, and then we'll get into some examples on how to actually get along, right? So we're just spending some time on identifying the u and then finding its du, right? And actually, you guys will see that the u is more important than you guys just think it is right now. So the angle of a trig in this case, this was probably one of the easiest ones, right? Because if I have sine of 7x, my angle of my trig, which is the inside of the parentheses, is going to be my u, which this one, number 5 and number 1, are kind of the same. The only difference is that here it doesn't apply when like a function is being raised to a power, right? So what we care about here is just the inside of the parentheses, the angle. So if you have 5x, 7x, those are going to be your u's. So in this case, our u is going to be 7x, therefore our du is going to be the derivative of that, which is 7 dx, right? So now we're done, and we got some pretty good experience picking out u's and picking out du's, right? And now it's time for us to move on to actually doing some examples. So the way we're doing this is we're going to break up USub into 3 parts, right? I'm going to make sure to do 2 examples of each type of problem, right? So in this case, in this video, we're going to do some examples on the inside of the parentheses only, right? We're only going to care about the inside of the parentheses. So let's go to example 1, and we're going to start off with first picking our u, right? So let's just scroll up for a second, and we know that we have our step box here, which you guys can see in your paper, but I really can't because I'm all the way down there. So we're starting off with first pick your u and find your du. And we're already pros at this because we did some examples on it already. So let's go ahead and do it for example 1, right? So in example 1, before we even do our step 1 or step 2, we're going to go ahead and get rid of this guy, because this guy is just a 5, and that is just to remind you guys of the constant rule of integrals. So I'm going to have a 2x plus 1 to the 3rd, and I just took out that 5. And now we're back to our initial problem when it comes inside of parentheses, right? So now, if we have to pick our u, I'm going to go do this in red. The u is going to be 2x plus 1, and our du is going to be 2 dx, right? And there's a reason why I always make the dx a different color, right? So once we've done this, once we do our step 1 or step 2, once we picked our u, which is the inside of the parentheses, and then we find our du, our third step is going to follow very nicely from what we did. Our third step is going to say to solve, we have to solve for dx, right? And that is why I made dx a different color, because that's going to remind you that, hey, I need to solve for dx in every problem. So let me go ahead and do that. If I need to solve for dx, right, if I need to solve for this guy right here, I just need to get rid of that 2. I need to get rid of this 2 right here that's next to my dx. And how am I going to do that? I'm going to divide both sides by 2. Therefore, this guy right here becomes du over 2. I just divided both sides by 2. So here it cancels on the right side. On the left side, I get du over 2, right? So your question might be, hey, what do I do next? And now, this may be a little tricky, but you guys will mean it. You guys will know exactly what I mean once we do the example of it. Substitute in terms of u. What do I mean by that? And what I mean is that we need to make everything in terms of u. But that means that if I have 2x plus 1, I let that equal to u, right? So in my problem, I am going to let that 2x plus 1 now equal to u, right? So that 2x plus 1 is now u, right? And now I have this raised to the 3rd, right? And now the reason why I solved for dx is because if you guys notice, this dx right here is going to replace this dx right here. So what I'm saying is that dx now is equal to du over 2. So now everything's in terms of u, which was exactly the meaning of this box right here. This whole box is a whole different meaning when we actually see an example. At first, it's just like, cool, sure, I believe you. But now you guys can see that we're going from f of x dx to f of u du, which means that here we have a function in terms of u, we have u to the 3rd, and then we have du over 2, right? But let's just be nice and take this 2 out and join in with this 5 outside, so we can just take out that whole constant, right? So we would have 5 over 2 in the front of this problem, and then we're just integrating u to the 3rd du, right? And that becomes a very simple integration now, because it's like just integrating x to the 3rd, right? Or a function to the 3rd, in which we do the reverse power rule, right? So instead of bringing it down and subtracting 1, we're actually going to add 1 and divide by that number. So let's go ahead and do that to integrate this function. We're going to go ahead and integrate this guy right here, right? And which is going to give us u to the 4th, right? We're going to add 1 to the exponent. We're adding 1 to the 3, so it gives us u to the 4th, and we're going to divide by 4th. And these two guys are multiplying, right? And then I am going to make sure that once I integrated, the du goes away, right? And I have to remember to always put a plus c, right? Because it's an indefinite integral, and when it comes to indefinite integrals, they're all about plus c's. So now that I have substituted everything in terms of u, and I already integrated, it just kind of like felt natural that I integrated, I am going to go ahead and do my last step, which is substitute u back in, right? So now that I'm done, I have integrated and I have, put my plus c, I'm going to go ahead and put my u back in, which I get it just from bringing this guy right here back into my equation, which that shows that I'm done. So I'm going to, before I even do that, I'm going to go ahead and simplify these two guys, this 3 and this 4, giving me a 5 over 12 in the front, a u to the 4th plus c. But my u is going to be 2x plus 1, right? So I'm going to put that guy here in red, 2x plus 1, because I made sure to bring down my u. Okay? And now we're done, because we started with a function in terms of x, and then we're giving them a function in terms of x at the end, right? So now we're fully done. And if you guys want to check out if this integration is correct or not, you guys are more than welcome to take the derivative and check if you go back to your original function. And that's the way we do it, right? So in this case, it just kind of became very natural to just follow the steps. In example 2, we're going to switch it up just a little bit by putting a function raised to a power, but we're also putting an x outside, right? I'm going to tell you the importance of that x being outside in just a second. So let's start off, right? And we start off again with our first two steps of picking u and then finding du, right? So let's go ahead and do that. Let's go ahead and pick u and find du. So if I want to do that, I'm going to go ahead and pick my u, which is this guy right here, right? The inside of the parentheses, raised to the 5th. So I'm going to have my u is equal to x squared minus 1, right? And therefore, I am going to go ahead and take my du, which is going to be 2x, right? 2x with my dx. So after I do my step 1 and 2, it leads me very natural to my step 3, which is solving for my dx, right? But how do you know if you're going, is there any checkpoint that I can say, or how do you know if you're going right so far, like if you're doing the problem correctly? Well, here you go. You already know, because you already did some examples, you already know that I eventually need to substitute in terms of u. So this guy right here is your u, right? And that guy is raised to a power, so that guy is good, right? And then you have your dx, and then you have your x left, and that you have to substitute. Do I have enough of that? And you'd be like, yeah, I have an x and I have a dx, because I have them right here. And you guys will see what I mean by that. Okay? So now, let's just keep going on with our steps. Let's just keep going on with our steps in which we solve for dx, right? So if I solve for dx, I'm going to go ahead and get du over 2x, right? Because I need to get rid of this guy right here. So I just divided both sides by that. And then I'm going to go ahead now and just substitute everything in terms of u, right? So I just make sure that I'm following my steps right. After I solve for dx, I'm going to go and substitute in terms of u. So let's go ahead and do that. I'm going to draw my integral. This guy right here is going to turn into u to the 5th, right? U to the 5th. So we're going to have x, u to the 5th. And then my dx is going to turn into du over 2x, right? So at first you were like, everything is not in terms of u because of this x right here that just keeps haunting me, right? But check it out. My du, or my new dx that I inputted, that came with an x that is actually going to cancel that other x out, right? So that's when you know that your problem was done correctly, because every x cancels out from the problem, right? So this guy and this guy, any function in terms of x has to cancel out from the problem. So that x and that x cancel. I'm going to take out this 2 out as a constant. So I'm going to have a 1/2 u to the 5th du, right? So now that we have made everything in terms of u, we can go up again and put a check mark on that one, because everything with an x canceled out. We can go ahead and say that we're ready to just integrate our function, right? So let's go ahead and do this. We have another anti-power rule in which we have a function raised to the 5th power. So let's just go ahead and integrate that by, this guy is a power, right? So how do we integrate? We add 1 and then we divide by that number. So we start off by first putting the 1/2 here. We're going to put the u, we add 1 to the 5, so we get 6, and then we divide by that same exponent, and then we put a plus c. So now that we're almost done, we're going to go ahead and simplify this. We're going to go ahead and simplify this because we have a 6 here and we have a 2. So we end up again with a 12, the 1/12 fraction looking answer plus c, right? And now our last step is going to be to make sure to substitute the u back in, right? So we need to go ahead and do that. So we have our answer in terms of u. That is no good. We want our answers in terms of x. So we bring our u back in. So somehow we're going to bring it back in. So let's do that right over here. So we're going to have 1/2, 1/12, u to the 6 plus c. And now we're going to bring our u back in which we're going to have x squared minus 1. So we're completely done now doing some examples on inside of parentheses type of functions, and then we're going to move on with the next 4 in the different videos based on u substitution. Right? So now that we've done this, we can now do different examples and we can switch it up with different types of functions in which we have to use the inside of a parenthesis as a function, right? So let's go ahead and some practice.